GPU cards. You can run also on VPU, and when I say VPU, I mean Visual Processing Unit, and it's for example, Movidius Neural Compute Stick 2. It's a USB accelerator, so you can plug into your USB port and you have external acceleration. In that case, you are not using your CPU, you are not using GPU, you are just using this device. And of course, you are able to run on FPGA with FPGA AI Suite. And it works on any operating system, Windows, Linux, or Mac. So what are the steps to use OpenVINO? So the first step is, of course, install OpenVINO. There are many ways to install OpenVINO. If you scan this QR code, there is a selection tool. You can click your configuration and you will get the best way to install OpenVINO in your situation. But as I said, you can use apt from Ubuntu, you can use yum from Red Hat or Fedora, you can use Docker image or Anaconda. But most of you are Python developers, right? So probably for you, the easiest way to install OpenVINO is using pip. Pip install OpenVINO and pip install OpenVINO dev for development package. So this was the first step, install OpenVINO. The second step is to use Model Optimizer. And Model Optimizer converts your model from original framework like Keras, TensorFlow, PyTorch into intermediate representation, which consists of two files, XML with architecture and binary file with weights and biases. But Model Optimizer not only converts your model to new format, it also performs some number of optimizations like graph pruning or fusing some operations together. How to use Model Optimizer? You need to install OpenVINO development package and use MO command line tool, giving some parameters like path to your model or desired precision. What precision can you use here? Floating point 32 and floating point 16 for even better performance. But if it's not enough for you, just this optimization, probably you heard about quantization, right? So you can do also quantization here in OpenVINO. You just need to use post-training optimization tool and provide your model converted to IR representation in floating point 32, for example, plus a representative data set. Use this POT and you will end up with IR format int8 version of your model. So first step, install OpenVINO. Second step, use Model Optimizer. And now it's time for the last step. Use OpenVINO Runtime to run the inference. And you need here this 7 lines of code. The first line, of course, import OpenVINO in Python. The next line, load your image or text or audio or any data. It could be anything. Then initialize OpenVINO by creating core object, read model from IR format, then compile model for specific device, in this case CPU, get the handle to the output layer, and run the inference, giving your input and getting the output from the output layer. So in the case of image classification, from this to this in just 7 lines of code. But there is natural question, what device can I put here? Of course, you can compile your model for a CPU, and it means that you will run on Core, Xeon, or Atom. You can also put here GPU. It means you will run on HD graphics, Intel UHD graphics, what is integrated GPU into your CPU. You can also use GPU to run on Flex series or ARC cards. If you put here Myriad, it means you will run on this device, Neural Compute Stick 2. But there are also many virtual devices like Hitero, and Hitero means split my graph into parts and run some operations on CPU, for example, and some operations on GPU. And why that? Because some operations could be faster on CPU and some of them could be faster on GPU. What else? Multi. Multi means copy my model across devices and run them in parallel. So if you have many frames per second, You can schedule some of them on GPU, some of them on CPU, and you process them in parallel, so you have higher throughput. But there is another question. So what device is the best in this case? Well, we recommend to use auto. Auto means that this device will select the best device, the best physical device for you automatically. So if you don't want to think and you don't know what is the best device in your case, in your need, you can use auto. Auto will select it automatically. And you can also provide some performance hints. Like, for example, you care about latency. So auto will create single stream. Well, first, auto will select one device from candidate hardware device list, and auto will create one single stream to all processing units and infer one by one. How to use latency? You just need to provide additional config that performance hint equals latency, and it will mean that you care about latency. What if you care about throughput? Almost the same. Auto will select the best device from the candidate list, create multiple streams, infer concurrently with optional auto batching, and the same like in latency, you just need to provide additional config. There is also one more mode called cumulative throughput, and in this case it means auto will select many devices, not just one, but many devices you have in your computer, for example, and of course it will create multiple streams, infer concurrently with auto batching, and will care about device priority you provided in config. So if you care about really high throughput, we recommend to use cumulative throughput mode. And of course, in code, it's called cumulative throughput as well. But we talked about frames per second, computer vision maybe, and so on. What if you work on NLP task or audio task when the input data can have different shape? So the standard usual way to deal with it is to just add padding at the end, right? So you are adding zeros at the end, or if the input is very long, you need to divide into parts and infer them one by one. But if you use dynamic shape from OpenVINO, you don't have to do it. OpenVINO will resize this network automatically when you just provide that input. So no more issues with that. And how to use dynamic shape? In this case, the code is almost the same to this point, and then you need to just get handle to the input layer, read the shape, assign -1. It means this shape will be dynamic. It means unknown. Reshape model and compile model for specific device once again. And what device can you put here? For now, only CPU, but we are working on this. So in the future, I think in the next version, next year, 2023, we will be able to assign here GPU as well. For now, CPU. Okay, but let's assume that you just started your journey with deep learning and you don't have any trained model. Well, it's not a problem. If you would like to use OpenVINO, we provide more than 270 pre-trained and optimized models, like object detection, pose estimation, action recognition, depth estimation, OCR. It works with Chinese, it works with English, and many more. So once again, if you just start your journey and you would like to use pre-trained models, you can scan this QR code. There is OpenModel repository on GitHub, and you can use any of these models. There was a question at the beginning, very important question. Is running on CPU still slow? And to answer this question, we performed some benchmarks, and we measured throughput in frames per second for floating point 32 model for three different models. ResNet 50 for image classification, SSD MobileNet V2 for object detection, and BERT base case for NLP model. And of course, the best results are for Intel Xeon. This is server CPU, so it's the most powerful CPU. But even if we just look at core CPUs, Core i9, i5, i3, the results are pretty good, right? So, for example, the cheapest and the weakest processor here, Intel Core i3 from 8th generation. 8th generation, it means that it's from 2018, so it's 4 years old. In case of image classification or object detection, you have more than 50 frames per second. And even in the most difficult heavy task here, BERT-based case, you have 15 inferences per second. I think it's completely enough in most cases, right? And if you would like to learn more about different devices, about different models, please just scan this QR code. There is a full page about different benchmarks. If you would like to benchmark your model when you convert it to OpenVINO, you can just run benchmark app command line tool and provide parameters like, of course, path to your model and desired device. And now is the time for the most exciting and interesting part of this speech. Let's run live code. Okay, so I prepared for you two different notebooks. The first one is live object detection with OpenVINO, so I would like to run this code with you to show OpenVINO performance and so on. So let's run the code, and meanwhile we are going to talk about the notebook itself. So first, of course, we need to import some Python packages, right? And especially OpenVINO in that line. Then we need to download the model. The model comes from OpenModel, so we can use command line tool called OMZ downloader, which is like utility from OpenVINO dev package. And we are going to download SSD Lite MobileNet V2 for object detection, of course. And this model, pre-trained model, is in TensorFlow format. As I mentioned before, we need to convert it to intermediate representation, also known as OpenVINO format. So we are going to use OMZ converter. This is another OpenVINO utility, and it's able to convert any model from OpenModel. If you would like to convert your model, you still need to use Model Optimizer directly. But in this case, when we use a model from OpenModel, OMZ converter is completely enough. Then we load our model, we initialize OpenVINO in this line, then we read model from the disk, compile model for specific device, in that case CPU, and then get the input-output nodes, get input size and similar things. Specify classes we would like to detect. All of them are from Coco dataset, so are rather common. Apply, specify colors for this classes. Function for post-processing, so we are creating boxes around objects, doing non-maximum suppression also here to get rid of many overlapping entities, and return, of course, labels, scores, and boxes. Then function to run boxes on the image. Main processing function, we are going to use video player. Is a class we implemented to stream video, to stream also webcam. And we are getting frame by frame. resize to fit neural network input size, create batch size equals 1, so we are inferring one by one, so our case is latency case. Then doing inference with time measurement here, and do post-processing, draw boxes on the image, calculating mean processing time from last 200 frames, put the inference time on the image, and show everything here directly in the notebook. So let's see the results. I think it works correctly. The label here is correct. I think I am person. And what's important here? I think the most important thing is inference time. You can see that there is 6.8 milliseconds, what gives us 150 frames per second. And I am just using CPU I have here. I am not using any additional hardware. I am not using discrete GPU card. This is just CPU I have here. But let's see what changes if I change just one line of code. So I'm going here and I'm going to change from CPU to GPU. So I'm going to use GPU, but it's not discrete GPU. It's this integrated GPU, like Intel. I think in this case it's Intel UHD graphics. Okay, let's run this code once again. And startup time is a little bit longer, like a few seconds, just a few seconds, because we need to compile OpenCL kernels for this GPU, but then we expect better performance. So previously we had 150 frames per second. If we run this code now with GPU, we have 180 frames per second. So 30 frames per second more, just changing one line of code. And I didn't buy any additional hardware. I didn't buy any GPU. I am just using what I have here. So I think this is like free lunch. I'm just utilizing whatever I have. And if you would like to run it at home, no problem, because this is open source. This notebook is here in OpenVINO Notebooks repository. So you can clone this repository and you can run it at home, try it and see what performance you have. If you don't want to use webcam or you don't have webcam, you can of course run the same code with video file, just provide URL here. So this was the first notebook I wanted to show you. Now I'm going to switch to the second notebook, and I'm not going to run it now because it takes more than 5 minutes, because this is like heavy notebook to quantize network additionally. So I pre-ran this notebook before this event yesterday evening, and I would like to show you the results. So this notebook is to quantize NLP model with post-training optimization tool to prove you that OpenVINO is not only for computer vision, but also to show you the performance difference between PyTorch model, OpenVINO model, and OpenVINO quantized model. Okay, so first, of course, we need to import some Python packages, especially OpenVINO POT here in these 2 lines. Then we specify some links, like we are going to use some additional data from this URL. We are, of course, downloading this data here. Then we need to export model to ONNX. Unfortunately, we cannot convert PyTorch model directly for now. We are working on this. But for now, you need to export model to ONNX first and then to OpenVINO. It should be rather straightforward to export any model from PyTorch to ONNX. It's supported, I think, in PyTorch directly. Then, of course, we are using MO model optimizer here to convert this ONNX model to IR format, intermediate representation. Then we download files, dataset, unpacking it, implement some classes like data loader and something like that. Then we need to also implement some other classes like accuracy. I don't want to stop here because we don't have much time. So I'm scrolling down. Of course, if you would like to learn more, this is also open source. This is also available in OpenVINO Notebooks repository. And then we specify pipeline to do the quantization. Of course, this pipeline is quite long for now, but I promise you that we are working on this. From the next version in 2023, it should be just 1 or 2 lines, so it will be not like 7 lines or 9 lines like now. But yeah, this is for current version. So yeah, it must be like that. So accuracy before converting the model, before quantizing the model, is 0.86, and after quantization, which took almost 60 seconds, the accuracy is a little bit higher. This is, generally speaking, this is unexpected. You should expect a little accuracy drop because of quantization, but sometimes in very, very rare cases, this works like a generalization. So this is that case. And of course, then we are running, we are initializing OpenVINO, running this model. We are assigning -1 here. It means we are going to use dynamic shapes. And let's skip this part, also this part, and let's go to the performance part. So we are going to run original PyTorch model for 50 samples, then compiled model, compiled means compiled for OpenVINO, converted to OpenVINO in floating point 32 precision, and then in int 8. And results are the follows. So in case of PyTorch model, we have 3.7 sentences or inferences per second. If you just convert this model to OpenVINO, you have more than 20. So it's like more than 5 times faster just converting your model and using this optimization from Model Optimizer. And I promise you, we are not changing the graph, the processing graph inside. We are just changing the format. We are fusing some operations together, doing optimization, but we are not changing accuracy at all. And of course, if you decide to go further and additionally quantize your network, you have 45 sentences per second, what is more than 10 times faster than PyTorch. But of course, this model is quantized, right? So you should expect a little accuracy drop, and of course, we should compare it to this model, PyTorch, not PyTorch model, but a floating point OpenVINO model, because PyTorch model in int8 would give us different results. So 5 times faster. In this case, it's not like that any case. No, in this case, specific case with this specific model and this specific hardware gives us 5 times faster inference. In your case, it could be 3 times faster. It could be 50% faster. It could be even 10 times faster. It depends on your model and depends on the hardware you have. Okay, let's go back to our slide deck. So the notebooks I presented to you comes from OpenVINO Notebooks repository. If you scan this QR code and run this 4 steps, create the environment, clone the repository, install requirements, and launch the notebooks, you will end up with the same results. So you can try them at home. But if you would like to test different Intel's hardware and you don't have different CPUs in at your home or GPUs or whatever, you can also use free access to Intel Developer Cloud for the Edge. There is a Jupyter Lab environment. You can run your experiments there and try different hardware and see the performance between them. And maybe you think here that I proposed to you something like proof of concept or something like that. No, OpenVINO was first launched in 2018. It's 4 years old and was already adopted by ecosystem. Maybe you recognize some companies which use OpenVINO. I could say that Accenture is rather recognizable, or what else? Hewlett-Packard, also Dell here, maybe something else. So this is fully production-ready solution you can use in your solution, for example. So my main 3 takeaways from today is that you don't need to buy any additional hardware to use OpenVINO. You can just utilize the hardware you already have. And even if you just run on your CPU, it should be faster than PyTorch and TensorFlow. And the third, that the easiest way to learn OpenVINO is OpenVINO Notebooks repository, so I really recommend you to try. So don't trust me, try it yourself and see what performance you have on your computer with your model. And before we go to the questions, I have a challenge for you. You can win this hoodie. You can also get this T-shirt. And what to do to get this T-shirt? I have more of them in different sizes. You need to fill this survey. So please come after this speech here to the first row. This is survey. If you fill it, and please leave your email address and name, otherwise I cannot contact you. So this is the first. Fill the survey and connect to me on LinkedIn. And to first 30 people, I will give you T-shirt. But also for one lucky person who filled this survey and connect to me on LinkedIn, I will draw this hoodie, right? So all of you, maybe not all of you, first 30 people who connect to me on LinkedIn and fill this survey, I will give you T-shirt. But one additional person will give, I will give them a hoodie also. Okay, so this is all from my side. This is QR code for my LinkedIn, so if you want to connect to me or if you want to ask me questions after this event, you can also drop me an email or ask at LinkedIn.
Thank you so much for your awesome presentation. Do you have any questions for our speaker?
I think there is a question. There is a question on the right.
So I have a question about, do I need to use Python, for example, to run this model? Because as I understood, this is continuation of Intel's development of neural networks compiler from 2018. And for example, if I want to create lightweight container without a bunch of Python stuff and run it in Kubernetes, for example, in streaming process, so can I do it with Vino?
Yes, we have three different APIs, Python API, C, and C++. So if you can use any of them, it's okay.
Yeah, I definitely can.
Okay.